Yes. Good evening, students. Today we discuss about very short answer questions regarding 2 marks. Now see the questions. Write the reagents. So in the last class, 8 marks question completed and 4 marks question completed. Now go for the 2 marks questions. Now see that. Write the reagents required to the conversion of what? Conversion of the benzene to methyl benzene. Simple logical question. Take the example of the benzene liquid. Now do this benzene liquid. Adding of what? Methyl chloride. Yes, on heating. In the presence of what? Anhydrous AlCl3. Lewis acid as catalyst. Now, because of the En difference, the bond shifted to chlorine side. Chlorine get negative charge and carbon get positive charge. Now the hydrogen removed as what? Hydrogen removed as H plus ion. Now the sigma bond carries what charge? Negative charge. CH3 plus. Attack on the carbon with what? Negative charge. And you got methyl benzene. What you got? Methyl benzene by loss of the HCl. So the reagent is what? Methyl chloride in the presence of anhydrous AlCl3. Lewis acid is the catalyst. That is completed, right? So one of the important 2 marks question. What is the answer right? Methyl chloride in the presence of anhydrous AlCl. See next question. How nitrobenzene synthesized? Simple logic. So benzene is heated with what? Benzene is heated with nitration mixture. So what is nitration mixture? Concentrated nitric acid and concentrated H2SO4 whose temperature is what? Whose temperature is below 60. Now, so we take that nitration mixture, the species comes out NO2 plus dot OH minus. Simple logic. If the hydrogen removed as what? Hydrogen removed as H plus. Right? H plus combines with OH minus loss of the water. Now the NO2 plus attack on the sigma bond. The sigma bond carries what charge? Negative charge, and you got nitrobenzene. Tell me what is forming? Nitrobenzene is forming. So this is the preparation of nitrobenzene. That means benzene heated with nitration mixture, temperature below 60, nitrobenzene is prepared. What is the other name of nitrobenzene? Other name of nitrobenzene is called Isle of the methane. Tell me, Isle of methane. By the conformations of the ethane. Simple logic, Nana. So we take the example of the ethane. In the ethane, so 2 carbons are there. So that is the first carbon and that is the second carbon. The first carbon is called what? Front carbon. The first carbon is called what? Front carbon. And this carbon is called what? Rear carbon. Back carbon is called what, Nana? Rear carbon. Now here, the front carbon keep as a dot symbol. To the dot, you write like this. To the dot of the carbon, 3 hydrogens are there like this. To the rear carbon, make a circle. Hydrogen write exactly opposite, exactly opposite, exactly opposite, and you get staggered form. Tell me what form is forming, students? Staggered form forming. The staggered form also called what? Transform. Staggered form also called what? Transform. Is also called what? Antiform. And next one. To the same front carbon, 3 hydrogens you write like that. CH, CH, CH. And the rear carbon make as a circle, right? Hydrogen very close, hydrogen very close, hydrogen very close. So this is called what? So eclipsed form. Tell me, students, what form? Eclipsed form. Eclipsed form is also called what? Is also called cis form. Simple logical question. So this has carries 1 mark, this carries 1 mark. You have what? You have the 2 marks question, right? Next one. Write structures of what? Trichloroethanoic acid. It means what? 2 carbons. Ethanoic acid, COOH. Trichloro. You write chlorine here, chlorine here, chlorine here. Trichloroethanoic acid. Neopentane. Pent means what? Pent means 5 carbons. You write CH3, 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 CH. That is a neopentane, right? And para-nitrobenzaldehyde. What you write para-nitrobenzaldehyde? Simple logic. So this is a aldehyde group. He is a orthoside, metaside, Parasite. A parasite NO2 group is there. This is called para-nitrobenzoylate. So this is called trichloroethanoic acid, neobentate, para-nitrobenzoylate. Orthosite, metasite, this is a parasite. Simple logical question. Understood, Nana? 2 marks questions. Very important. Organic 2 marks questions are very important. Understood, Nana? Please respond. Come to the chart. Discuss Lezine test. Simple explanation, Nana. So the test is used by the one small statement. Test is used to identify the presence of what? To identify the presence of nitrogen, sulfur and halogen atoms present in the given organic sample. Present in the given organic sample. Simple logic. Present in the given organic sample. Sample may be solid or may be liquid. Understood? For example, in the organic compound, nitrogen is available. Along with the organic compound means carbon hydrogen definitely present. Organic compound having carbon hydrogen definitely. Nitrogen present along with the carbon. Now in the Lezine's filtrate, nitrogen available in the form of sodium cyanide aqueous solution. So for example, sulfur is there. Sulfur is available in the form of what? Sodium sulfite. What you get? Sodium sulfite aqueous solution. If halogen is there, the halogen is available in the form of what? NaX. How is available? NaX aqueous solution. Sodium cyanide aqueous solution. Sodium sulfate aqueous solution, NaX aqueous solution. That is the use of the Lezine test. Repeat the statement once again. The Lezine test is used to identify what? To identify the nitrogen atom, to identify the sulfur atom, to identify the halogen atoms present in the given organic sample, may be solid or liquid. If nitrogen is there, is available in the form of the sodium cyanide aqueous solution. Sulfur is there, is available in the form of sodium sulfite solution. Halogen is there, is available in the form of the sodium halide solution, right? So, as per the 30% clinical syllabus, chromatography, so the purification methods are not there, right? And this is the purification methods, these purification methods are not there as per the 30% syllabus is concerned. So, crystallization, distillation, stream distillation and distillation under temperature is not there, right? See next one. How ethylene is prepared from ethyl alcohol by the reaction. Ethylene. You take the example of the ethyl alcohol. CH3, CH2, OH. So this is an ethyl alcohol liquid. To this ethyl alcohol liquid, adding of what? Concentrated H2SO4 at temperature of what? 170. Exactly at 170 what happens? Dehydration happens. What is dehydration? Removal of the water. H plus from here and OH minus from here. Now loss of the water and you get what? And you get ethene gas. Tell me what is forming? Ethene gas is forming. This is the simple explanation. Understood, Nana? Ethene gas also called what? Ethene gas also called ethylene gas is forming. Nana is very easy, Nana. Next one. What product formed when sodium propionate heated with what? Sodium propionate heated with the soda light. Simple logic. What is sodium propionate? CH3, CH2, COONA is a sodium propionate. Heat with what? Soda light. What is soda light? NaOH in presence of what? NaOH in presence of the CaO on heating. Understood? Now here the CO2 gas is lived in the form of Na2CO3. Tell me what I am saying, student. The CO2 gas live in the form of what? Na2CO3. Now this H atom attack on what? The H atom attack on this ethyl group and you get ethane gas is liberated. Tell me what is liberated, students? Ethane gas is liberated. Simple explanation. That's why here the CO2 gas is removed in the form of the soda ash. Or the CO2 gas is removed in the form of soda ash. Next one. What is dehydrohallucination? By the equations for formation of alkene from alkyl halide. Now see, dehydrohallucination. Removal of the hydrogen gamma halogen atoms by using of the strongest base. So this is ethyl chloride. To that, heat with what? Sodamide. What is sodamide? Na plus NH2 minus. Heat with what? Heat with the sodamide. Repeat once again. What is sodamide? Na plus NH2 minus. Understood what I am saying? Okay. So sodamide means what, Nana? Na plus NH2 minus. So sodamide is the what? Strongest base. The strongest base of the NH2 minus, remove the one of the is a alpha carbon, is a beta carbon. One of the beta has removed as what? Removed as the H plus. Now H plus combines with NH2 minus. Loss of the NH3. Now halogen is removed as what? X minus, and this is what? C plus. Loss of NaX, and you got CH2 double bond CH2, you got like this. So there is ethene gas is forming. Tell me what is forming? Ethene gas is forming like that. And see the next one, IUPAC. Out of the double bond and single bond, priority goes to what? Out of the double bond comma single bond, priority goes to the single bond, right? So this is 1, 2, 3, 4, 5. So priority goes to the double bond. Now 5 carbons are there, which one is pent, right? So between the carbon double bond is there, pent 1A. IUPAC name of the molecule. And come to this one. By write like this, CH3, CO, CH2, CH2, CH3. Now by giving numbering to this molecule, so here the function group ketone gets least number. So you get 1, 2, 3, 4, 5. Totally 5 carbons are there. So because of 5 carbon, the root word is what? Pentane. Between the carbons are single bonds. Pentane to 1. For the molecule, pentane to 1. Right? Again, write this example. CH3, CH2, CO, CH2, CH3. Now take the example. 1, 2, 3, 4, 5. Totally 5 carbons are there. So what you write? Pentane 3, 1 you write. Then what you write? Pentane 3, 1. Simple logic. And this is also another beautiful bit. Pentane 2, 1 and pentane 3, 1. These two are examples of what? Metamers. Examples of what, students? Metamers. And take this example. CH2, CH, CH, CH2. Now by giving numbering. So what you write here? 1, 2, 3, 4. Totally 4 carbons are there. That's why this is called buta. Buta 1, 3 diene. Its IUPAC name is what? Buta 1, 3 diene. Come to this one. So number 1, number 2, number 3, number 4. You write as what? 4-nitro. What you write, Nana? 4-nitro benzene carbaldehyde. Benzene 1 carbaldehyde. 4-nitro benzene 1 carbaldehyde. IUPAC name of this molecule. Understood what I am saying, students? This is called 4-nitro benzene 1 carbaldehyde. This is called buta 1, 3 diene. Simple logic, right? Now you the next one. Structural formula of the given compounds. What I am discussing now? Structural formula of the given compounds is Nana. So heptane. Hept means what? Hept means 7 carbons are there. So 1, 2, 3, 4, 5, 6, 7. So here numbering is given. Is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, okay, and sixth carbon, and next one is what? Seventh carbon. Understood what I am saying? Understood what I am saying? Nana is clear? Is first carbon, second carbon, and what? Third carbon, fourth carbon, like that. Clear, Nana? Any doubt you having that? Right. Now see then. Now regarding that point. Now 3, 4, 5. So on third carbon, here you write methyl group. Third carbon, you write methyl group. and fourth carbon you write methyl and you write methyl, and fifth carbon you write methyl, just like carbon valence is 4. You keep CH, CH2, CH3. Here CH valence is 4 na, CH2, CH. The structure of what? Structure of what? Now see that. So 7 carbons are there. 3, 4, 4, 5 tetramethyl heptane. Right, Nana? And see the next example. 2 methyl, 1 butene. That means what? Again 4 carbons are there. 1 butene means what you write, Nana? So you write like this. So this is 1 butene, 2 methyl. On second carbon methyl group is there. Simple logic, no confusion, students. So this carries 1 mark and this carries what? Okay, 1 mark. Understood what I am saying? Nana is clear. Any doubt we have it. So in this way, 2 methyl, 1 butene, 2 methyl, 1 butene. Is clear? Yes, Nana. Please tell me your doubt. Right. So here's what? 2 methyl, 1 butene. And see the next example. Write structures of the following compounds. 2,4-dimethyl pentane. 2,4-dimethyl pentane. Pentane means what? 5 carbons are there like this. Understood? 2,4. That means on second carbon methyl group is there. On the fourth carbon methyl group is there. And carbon valence is what, Nana? Carbon valence is 4. You write CH3, CH, CH2, CH, CH3. Shashank, what you said, Nana? Sir, you are a scammer. That means what? I don't understood what you said. Whether that Venkatreddy profile appear like a board profile, appear like a board image. That's why I check where that is a classroom board like that. What you post, Shashank, I don't understood. We are the nice lecturers, nice, beautiful lecturers. Is there the image of the Venkatreddy appear like a board image where that classroom board is there? That's why checking like that, right, Nana? So you have the minimum common sense. What you post on this chatting. Clear what I am saying, Shashank? The minimum common sense, Nana. Okay. So that is next one is what? See the next one. 3-ethyl 4-4-dimethyl heptane. Okay, right? Shashank, you respond. Please respond. Nana, Shashank, please respond. 3-ethyl 4-4-dimethyl heptane. Heptane means what, Nana? 7 carbons. 4, 5, 6, 7. So 3-ethyl. That means number 1, number 2, number 3, 4, 5, 6, 7. Understood? So 3-ethyl. That means what? Here you write ethyl group. Right. 4-4-dimethyl. 4-4-dimethyl. You write like that. So carbon valence is 4. You keep CH2, CH2, CH3, CH, CH2, CH3 like that. That is the structural formula of the given compound. 3-ethyl. Tell me what I have said. 3-ethyl 4-4-dimethyl heptane. Okay, Nana? In full of the my tensions of the teaching job, what I can see, brother Shashank, please think about that. The Venkatreddy image appear like a board image. That means that is a classroom board or a school board image. That's why check that what image is there. Hare Shashank, what you they posting? And see next one. Write a short note on what? Write a short note on Woods reaction. Okay. Now see, write a short note on what? Woods reaction. For example, Nana, take the one of the best example of Woods reaction. How you take the example of Woods reaction? So simple logic, Nana. 2 moles of the similar kind of alkyl halides are taken. Ethyl halide. 2 moles of the similar kind. Heat with the sodium metal. Heat with what, Nana? Sodium metal. In the presence of what? In the presence of dry ether solvent. Just on heating, what happens? So here sodium metal react with what? Halogen. Leave in the form of what? Leave in the form of 2NaX. And you get what? And you get butane gas is liberated. This is what, Nana? So this is Woods reaction. Simple explanation. Have no confusion. Clear what I am saying? Yes, Nana. So 2 moles of the what? 2 moles of the ethyl halide react with the sodium metal. So in presence of diethyl solvent, and what you get? In presence of diethyl solvent, and you got butane gas, that is the Wood reaction. Simple explanation. Come to the Friedel Craft alkylation. That is also given in the previous class also. What is Friedel Craft alkylation? Take the example of the benzene nucleus. To this benzene nucleus, so adding of what? Alkyl halide. Better to add alkyl halide because alkylation is there. Na? Halogen is the best living group. We can use AlX3 on heating. Halogen leave out as what? X minus R plus. Understood what I am saying? Yes. Now one of the hydrogen leave out as what? One of the hydrogen leave out as a H plus ion. H plus ion combines with X minus ion, loss of HX. Now here sigma bond carries what charge? Negative charge. That's why the R plus attack on the sigma bond with negative charge, and you got alkyl benzene. Tell me what you got, Nana? You got alkyl benzene. Understood what I am saying? That is called Friedel Craft calculation. Now see next one. So this molecule is given. In that molecule, ask about hybridization of the each carbon atom. Hybridization of what, Nana? Each carbon atom. I said one simple logic. What is simple logic? I said carbon have 4 sigma bonds, that is sp3 carbon. Carbon have 3 sigma bonds, sp2 carbon. Carbon having 2 sigma bonds, that is an sp carbon. Clear what I am saying? Carbon have 4 sigma bonds, sp3 carbon. Carbon have 3 sigma bonds, sp2 carbon. Carbon having 2 sigma bonds, sp carbon. Now based on that, now see brother, so this is a sigma bond, pi bond, sigma sigma. This carbon having 3 sigma bonds, 6 electrons, sp2 carbon. Single bond always sigma sigma. This carbon have 3 sigma bonds, sp2 carbon. This carbon have in the triple bond, pi bond is a sigma bond. This carbon having 2 sigma bonds, sp carbon. This carbon have 2 sigma bonds, sp carbon. That's why, so this is 2 sigma bonds, sp, 2 sigma bonds, sp, 3 sigma bonds, sp2, 3 sigma bonds, sp, 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 sp2, sp. Understood what I am saying? Clear, Nana? Easy explanation, Nana. If carbon carries 4 sigma bonds, sp3 carbon. If carbon carries 3 sigma bonds, that is what? sp2 carbon. And the carbon having 2 sigma bonds, that is what? sp carbon. Simple explanation, Nana. Right, next example, brother. Where the following reaction with the equation polymerization of ethylene is very easy, brother. So ethylene is subjected to polymerization under high pressure in the presence of what? In the presence of the O2 gas, and you got polythene. Simple explanation. So the pi bonds are breakdown, and pi bonds are breakdown and forms the single bonds like that. You get H, 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 H like that, and you get polythene is forming like this, and you get polythene. As you are very well known, polythene is used as a polymer. Simple explanation. Where the pi bonds are breakdown, the pi bonds add up. Because one pi bond having what, Nana? One pi bond. This pi bond is breakdown. This pi bond has 1 electron. This pi bond has 1 electron. Electrons are add up and form the single bonds between the carbons. That is called polythene polymer is forming. And see next one, Nana? Where functional isomers of what? C3H6O. So what you write? C3H6O. CH3, CO, CH3, ketone. And what you write? CH3, CH2, C double bond OH. So ketone carbon aldehyde. Now what you write, Nana? CH3, COH, and you write what? CH3. Examples of the functional isomers of what? C3H6O. Now here, in the 3 functional isomers, here the CO group is called, ketone, right, Nana? And here, and what you write, Nana? Hello? 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 So this is called what, Nana? This is called aldehyde group. Tell me what group, Nana? Aldehyde group. And this is called what, Nana? Alcohol group. That's why for the molecular formula of the C3H6O, so 3 functional isomers are possible. So one is called ketone is possible, Nana. Other one is called aldehyde is possible, brother. Other one is called what? Alcohol is possible. Simple explanation, no confusion of the explanation. Clear? Yes. Right, very good. And go to the next example. So this is over, Nana, and go to the questions of the states of the matter. So organic chemistry successfully completed, brothers. Organic chemistry is successfully completed, and go to the next questions of the states of the matter. One of the nice topic. Now the topic of the states of the matter, only the 4 marks questions are important. Yesterday and today, we complete the essay questions of organic chemistry, 4 marks questions. And you subscribe to the Rules Academy channel, those questions are appeared. Free classes are there in the Rules Academy channel. If anybody wants the reference for the previous 4 marks and 8 marks questions of IPE, so is there in the Rules Academy channel, check the channel in the YouTube. And now come to the states of matter, only 4 marks questions are important. Right, the first question, write postulates of kinetic theory of the gases. That's very easy. First postulate is what? So, the gas molecules are what? The gas molecules are composed of smallest tiny particles. Tell me what I am saying. The gas molecules are composed of the smallest tiny particles. What is the meaning of tiny particles? Simple particle, very small size of the particles. Second point is what? Between the gas molecules, what I am saying, between the gas molecules, neither force of attractions nor force of repulsions are present. Neither forces of attractions, nor forces of repulsions, nor forces of the repulsions are present, or what, Nana? Are present. That means what? Force of attractions and force of repulsions are absent. Neither nor means what? Absent. Understood, Nana? And second point is what? So the average kinetic energy of the gas molecules. Tell me what I am saying. The average kinetic energy of the gas molecule directly proportional to the temperature on the Kelvin scale. Tell me what I am saying, Nana. The average kinetic energy of the gas molecules directly proportional to what? Temperature on the Kelvin scale is the third postulate. And see the next postulate. The volume occupied by the gas molecules, volume of the gas molecules neglected, volume of the gas molecules neglected compared with total volume of the vessel. Compared with what? Compared with the total volume of the vessel taken. So why the total volume of gas molecules are neglected when compared with total volume of the vessel taken? Because of the very small size. Total volume of what? Vessel taken. Repeat the point once again. So the volume of the gas molecules are neglected. Repeat the point once again. The volume of the gas molecules are neglected compared with what? Total volume of the vessel is taken because of the very small size. Understood what I am saying, Nana? Now the beautiful nice point. Now see the next point. The collisions between the gas molecules. What I am saying? Collisions between the gas molecules. The collisions between the gas molecules are elastic nature. What I am saying? The collisions between the gas molecules are elastic nature. That means what? During collisions, what I am saying? During collisions, neither no loss of energy, no gain of energy. Neither lose nor gain of energy absorbed. Gain of energy is what, Nana? Gain of energy absorbed. That means the collisions are what? Elastic collisions are absorbed because of the ideal gas molecules. Understood what I am saying? And see at this point, the gas molecules are not affected by gravitational force. What I am saying? The gas molecules of the given gas, what I am saying, Nana? The gas molecules of the given gas not affected by the gravitational force. Not affected by the gravity. Gravity means what, Nana? Gravitational force. So these are the 4 important postulates of the kinetic theory of the gases, right? And see next one. So it used Boyle's law, Charles' law, Graham's law, Dalton's law from kinetic gas equation. One of the excellent concept now. I think so. Without giving this question, there is no examination paper. I think so. Without giving this question, have no examination paper. First, you know kinetic gas equation. PV is equal to 1 by third mn c square, RMS velocity square, for number of the moles of the gas given mass by molecular weight. Generally, in the experiment, we take what? In the experiment, number of moles of gas is taken as 1 mole of gas is taken student. Understood what I am saying? Simple explanation. If the 1 mole of the gas is taken, now the small m is taken as what? Capital M. Now, basing on that, what you write? PV is equal to 1 by third capital M RMS velocity square. Understood what I am saying? So, from this, what you write? PV is equal to, if I am writing like this, any problem? So, how I am writing? So, I am writing like this, 2 by 3 into half m RMS velocity square. If I make like this, any problem? 2 by 3 because half of is cancelled, you get 1 by 3. Half into mc RMS square is nothing but what? Kinetic energy of the gas. That means what you write? PV is equal to 2/3 of what? 2/3 of the average kinetic energy of the gas. Understood what I am saying? Repeat once again, Nana. PV is equal to what you write, Nana? 1 by third small m n RMS velocity square. Number of moles of the gas equal given mass of the gas by molecular weight. So number of moles of gas is what? 1 mole of gas is given, small m is equal to capital M. So PV is equal to 2 by third into half into mc RMS square. Now half into mc square is nothing but what? Average kinetic energy. You are very well. So what is average kinetic energy? Average kinetic energy nothing but 3 by 2 RT. What I am saying, Nana? Average kinetic energy is nothing but what, Nana? 3 by 2 RT. That means you take up this average kinetic energy as what? 3 by 2 RT. Any doubt? So from that what you get? PV is equal to 2 by third into 3 by 2 RT. Now this 2 cancel, 3 cancel. Now what you get? PV is equal to RT. Now here R is constant. What is Boyle's law? Boyle's law means what? A temperature constant, PV is equal to K. That is a Boyle's law is derived. Simple explanation, Nana. Are Nana, what I am saying? So Boyle's law is derived like that. Nana, understood what I am saying? So average kinetic energy is equal to 3 by RT. So here at the place of average kinetic energy, write what? 2 by 3 into 3 by 2. 2 by 3, 3 by 2 cancel. So at constant temperature, PV is equal to K, like that. And come to the Charles law. Come to what, Nana? Charles law. That is very easy. Now, how we discuss the Charles law? Graham's law, that is not important. But the Boyle's law, Charles law is very important, Nana. Right, Nana? And again, what you write? PV is equal 1 by third m into RMS velocity square. From that, what you write? PV is equal to, so you write like this. So half into m RMS velocity square into what you write? You write as a 2 by 3. Understood? Yes, because 2 to cancel, you get 1 by 3 now. Now PV is equal to 2 by 3 of what? Average kinetic energy of the gas. So you are very well known. What you are very well known? Average kinetic gas means what? PV is equal to 2/3 into average kinetic energy 3 by 2 RT is cancelled. What is Charles law? At constant pressure. Tell me, Nana. At constant pressure. At constant pressure, what you know? So volume of the gas is equal to RP. R itself is a constant. That means volume of gas proportional to temperature. Volume of gas proportional to what, Nana? Temperature, that is called Charles law 2. It's called what law? Charles law 2. Understood what I am saying, Nana? Simple logic. But Graham's law, Dalton's law, they are not important. But these two are very, very important. And go for next one. So state and explain the Graham's law of diffusion. State and explain what Nana? Graham's law of diffusion. Simple explanation Nana. According to the scientist Graham's law, according to this law, so the rate of diffusion of the gas, tell me what I am saying, rate of diffusion of the gas inversely proportional to square root of what? Molecular weight of the gas, or inversely proportional to square root of vapor density of the gas, or inversely proportional to square root of the density of the gas. Simple explanation. Repeat once again the explanation. The rate of diffusion of the gas, tell me what I am saying. The rate of diffusion of gas proportional to 1 by square root of the molecular weight of the gas, or 1 by square root of the vapor density of the gas, or 1 by square root of density of the gas. And from that what you write now? So R1 by R2 is equal to root over M2 by M1. You write R1 by R2 is equal to root over VD2 by VD1, or what you write? R1 by R2 equal to root over D2 by D1. How you write the problems on the Graham's law? Now the problems on Graham's law is very easy. How the 2 marks questions are given on the Graham's law? We check out what 2 marks question brother. It's very simple. The problems on Graham's law. How the questions are given brother? A question is given like that. See, for IPE the questions are very easy. So what is the ratio of rates of diffusion? What is the ratio of rates of diffusion of? What is the ratio of rates of the diffusion of methane gas and helium gases? Now what you write? Rate of diffusion of the methane by rate of diffusion of the helium is equal to root over molecular weight of the helium by molecular weight of the methane. Now from that what you get? So inversely proportional to molecular weight now from that. So molecular weight of the helium is 4, molecular weight of the methane is what? 16. You get 1 by 4. So 1 by 4 means what? 1 by 2. That is equal to 1:2. The question is given like that. For example, the question given like this. What is ratio of, simple question given like this now. Rates of diffusion. What is the ratio of rates of diffusion of H2 gas and helium gases? What is the ratio of rates of diffusion of what? H2 and helium gases. Now regarding that statement, what you write? Rate of diffusion of H2 gas by rate of diffusion of the helium gas is equal root over molecular weight of the H2 gas by molecular weight of what? Helium gas. By that, so H2 gas is 2 and helium gas is 4. So from that what you get? 1 by 2. You get 1 by root 2. So 1 by root 2 means what you get? 1:1.414. What is the answer? 1:1.414. Is clear what I am saying? The ratio of rates of diffusion of what? H2 comma helium gases. Yeah, IPE questions na. The IPE questions very easy questions given like this na. Not so much difficulty questions are given in IPE point of view. I am saying. Okay. Say for example, one more question. So one more the question is given like this na. For example, the question is given like this. What's the ratio of rates of diffusion of SO2 gas and SO3 gases given like that. Okay. Now simple logic brother. Rate of diffusion of SO2 by rate of diffusion of the SO3 is equal to root over inversely proportional to molecular weight now. Molecular weight of the SO3 by molecular weight of the SO2. Now basing on that, this is 80 and this is 64. So from that we get this is 40 and this is 64 na tamudu and okay, you keep like this 40 and this is 32. Understood? Now this is what 10 times. This is root 10. This is what 8. Now this is what root 10 by 2 root 2. What is the answer here? Root 10 is 2. 2 root 2 you get like that. Because IPE questions, not so much difficult questions are given. Nana, it's clear what I am saying? Yes, Nana, was very good. Now see the next question. State and explain the Dalton's law of the partial pressure along with that problems. Problems means as per objective, difficulty problems are not given. Simple problems are given. So how you define Dalton's law? Simple statement. So the Dalton's law is defined as what? The Dalton's law is defined as, first of all, Dalton's law is applicable for what? Non-reacting gas or reacting gases. So according to the statement of what? According to the statement of Dalton's law, how you define Dalton's law? So at given temperature, what am I saying, brother? At given temperature, so total pressure exerted by all non-reacting gases, total pressure exerted by all non-reacting gases equal to the summation of partial pressures of all gases. Summation of what, Nana? Partial pressures of all gases. That's the simple statement. Understood? Repeat once again. At given temperature, that may be the temperature. What is temperature is given? So at given temperature, the total pressure exerted by the all non-reacting gases equal to summation. Summation is what? Add up of partial pressures of the all gases. That is called Dalton's law. Now, how we define the partial pressure? So, partial pressure how is defined? Partial pressure is defined as what? Partial pressure of the gas. Partial pressure. The partial pressure of the gas defined as the pressure exerted by the one gas, among the all non-reacting gases. Repeat the statement, Nana. Repeat what I am saying. Partial pressure of the gas is defined as the pressure exerted by the one gas among all non-reacting gases at given temperature. At what, Nana? At given temperature. That's the meaning of what? Dalton's law of partial pressure. Now in the examination, how the problems are given? Now in the examination, the simple problems are given. What I have said, Nana? The simple problems are given. For example, the question is given like this. Calculate partial pressure exerted by O2 gas by mixing of O2 and N2 gases in the moles ratio of 1:2 at 10 atmospheres. Simple question. I said, repeat once again. In the IPE paper, difficulty questions, objective questions are not given. Simple questions are given. Calculate the partial pressure exerted by O2 gas by mixing of what? So O2 and N2 gases in the moles ratio of what? 1:2 at pressure of what? 10 atmospheres. What you write? So the partial pressure exerted by the O2 gas is equal to mole fraction of the O2 gas into total pressure. Understood? What you write? Mole fraction? Number of moles of O2 gas by number of moles of O2 gas plus number of moles of the N2 gas into total pressure is 10 atmospheres, that is equal 1 by 3 into 10 atmospheres, that is equal, the partial pressure of the O2 gas is what? 3.3 atmospheres. You want partial pressure of the N2 gas? So total pressure is equal partial pressure of the N2 plus partial pressure of the O2. Total pressure is what? Total pressure is 10 atmospheres is given. Therefore, minus 3.3 atmospheres of the O2 gas equal partial pressure of the N2 gas. That becomes what? 6.6 atmospheres. What is the 6.6? The 6.6 is the partial pressure of what? That is the partial pressure of the N2 gas. Understood? The simple questions are given like that. See, one more question given like this, Nana. See, one more question is given like this. For example, see, by mixing equal masses, by mixing equal masses of helium gas and methane gas at 10 atmospheres pressure, okay, calculate partial pressure exerted by the helium gas. Simple explanation. By mixing equal masses of what? Helium gas and methane gas at 10 atmospheres pressure, calculate the partial pressure exerted by the helium gas. Okay, now see that. Simple logic, no confusion. Right, Nana? Now see that. So because of equal masses, because of what? Why you take, sorry Nana? No problem, Nana. Why you explain to me sorry? Arey brother, please tell me, why you keep sorry there? No problem, brother, no problem. So equal mass now the mass of helium is taken as 1 gram and the mass of the methane is taken as what? The mass of methane taken as 1 gram each. Why take 1 gram? Because of what? Equal mass. Understood, Nana? But you want the partial pressure of the what? Helium gas equal what you write? Mole fraction of helium gas into what? Total pressure. So first for mole fraction you write number of moles of the helium. So 1 by 4 moles, right, Nana? And number of moles of what? Number of moles of the methane. For number of moles of methane, what you write, Nana? 1 by 16 moles. Understood what I am saying? Now, based on that, so 1 by 4 moles by 1 by 4 plus what? 1 by 16. Into total pressure is what? 10 atmospheres. So from that, so what you write? Here 16 is the 1 by 4 and 16 is the common factor. You get 5 by 16 na? Because LCM is what, Nana? LCM is 16. 4 ones, 4 fours into what? 10 atmospheres. So from that, what you get? You get 4 by 5 into 10 atmospheres on cancellation, and you get what? 8 atmospheres. Therefore, the partial pressure of the helium gas is what? The partial pressure of the helium gas is 8 atmospheres. It's clear, Nana? Yes. No, for example, ask about what, Nana? So partial pressure of the methane gas is asking. Yes, you are very well known. So partial pressure of the helium gas plus partial pressure of the methane gas is equal to total is what? 10 atmospheres. Right? Now the partial pressure of the helium gas is what given, brother? 8 is given. Therefore the partial pressure of the methane gas you get as 10 minus 8, that is equal to 2 atmospheres, like that. So the simple questions are given like this on the concept of what? On the concept of Dalton's law of partial pressures. Answer the next question. So define RMS, average, most probable velocities, give the relationship. One of the beautiful bit. So first you have to write the RMS speed. RMS speed means what? Simple statement. Root mean square velocity of the gas molecules. Tell me. Root mean square velocity. Therefore, CRMS equal root mean square. RMS velocity means what, Nana? Root mean square. That means what you write? N1 C1 square plus N2 C2 square plus N3 C3 square, so on like that, by what you write? N1 C1 plus N2 C2 plus N3 C3. Root means square, and you make a whole root like that. That is called root mean square velocity. Now one more formula is there. What is the formula? C RMS velocity is equal root over 3 PV by M. So that equal what you write? Root over 3 RT by M. So you are very well known. Mass by volume is what? Mass by volume is called density. Root over 3 PV, root over 3 P by D. And next one, come to the average velocity. So what is the simple formula of the average velocity? So first of all, how you define average velocity? Average velocity means the velocity possessed by the molecules on its average motion. Tell me what I am saying. This statement is very important. Velocity possessed by, tell me brothers, velocity possessed by the gas molecules, velocity possessed by the gas molecules on its average among total molecules. Among what, Nana? Among total colliding molecules. Among total colliding molecules. Understood what am I saying? Velocity possessed by the gas molecules on its average among total molecules is called what? Average velocity. So what is the formula for average velocity? Therefore, average velocity C is equal to root over 2RT by root over 8RT by pi m. So what is the formula? Root over 8RT by pi m, the formula for what? So average velocity. Come to the most probable velocity. Now regarding the most probable velocity, what is the formula you write? So most probable symbol is what, Nana? Cp. How you define the Cp? So the velocity possessed by, what I am said, the velocity possessed by the maximum fraction of the molecules. Velocity possessed by the maximum fraction of the molecules among the total molecules. You know what I am saying? Among the what, Nana? Among the total molecules. Simple statement. Repeat the statement once again. What is Cp, Nana? The velocity possessed by the what? Maximum fraction of the molecules among the total molecules is called most probable velocity. Therefore, most probable velocity Cp is equal to root over 2RT by M. That is equal to root over 2PV by M. That is equal to root over 2P by D. Now ask me about what? Relation. The relation also very important, Nana. Cp means what? Most probable velocity is to C bar. C bar means what? Average velocity is to, and CRMS. So from that, what you write for that? From that, most probable velocity means what? Root over 2RT by M, and average root over 8RT by pi M, right? And RMS root over 3RT by M. Who is the common factor? RT by M, RT by M, RT by M is the common factor. Now common factor is the RT by M. What we get? You get root 2 is to root 8 by pi is to root 3. So from that, so root 2 means what you write, Nana? 1.414 is to 2 root 2 by root 5. And what is this? 1.73. It is all simplified. You get 1 is to 1.128 is to 1.224. Tell me what I am saying. 1 is to 1.128 is to 1.224. Simple logic, no confusion. Repeat explanation once again, Nana. 1 is to 1.128 is to 1.224. That's the relation between the most probable, average, and RMS. Repeat once again. Most probable, average, RMS. Right, Nana? And see next question. Find out the RMS most probable speeds of CO2 at 27 degrees. Yes, Nana? Take the example of the RMS velocity. Root over 3RT by M. This is unsimplified, you get 1.54 into 10 power 4 centimeters per second root over T by M is the formula, shortcut formula. So 1.54 into 10 power 4. So temperature is what, Nana? 300 by, this is SOD is what? 64. Are Nana? SOD is what, Nana? 64. So actually root 3 R value in the X, 8.314 10 power 7 Nana. Root 3 value 1.732. R value 8.314 into 10 power 7 X, and simplified you get like that, 1.54 in 10 power 4 centimeters per second. Understood, Nana? Into root over T by M. Yes. Now unsimplified, what you get, Nana? 1.54 into 10 power 4 centimeters per second. So root 300. Root 300 means what you get? Root 3 means what? 1.732 into root 100 means what? 10 by 8. Understood, Nana? These are simplified, you get the value. Easy logics, brother. No confusion of the logics. Okay. Now you get 1.54 into 1.732. You get like that. Okay. Divided by 8. You get 0.33 into 10 power 5 centimeters per second. Understood, Nana? Yes, that is what RMS velocity. Now the relation is there, Nana? CP is to what? CRMS. What is relation? 1 is to 1.224. Therefore, what you write, brother? Basing on the relation. Before I said, brother, this is the relation I said, now. Basing, this is what? 1 is CP value. This is what? C average value. This is what? C RMS value. Right. Now based on that, what you write, brother? CP by C RMS is equal 1 by 1.224. Now C RMS value substitute here and you get CP value. Therefore CP is equal to 0.33 into 10 power 5 by 1.224. And you get what? 0.2 divided by 1.224. You get 0.29 into 10 power 5 centimeters per second. Simple logic, Nana. And the last one, Nana. Last one. Now see. So C average. Average velocity into is to C RMS. What you get? 1.128 is to 1.224. And you get what? C bar by C RMS is equal to 1.128 by 1.224. So, what is the C RMS given? Therefore, C bar is equal. What is the C RMS? 0.33 10 power 5. 0.33 into 10 power 5 into 1.128 by 1.224. So, from that, you get what? 0.33 into 1.128 divided by 1.224 and you get 0.3 into 10 power 5 centimeters per second. That is for what? C average. So this is your previous class questions, Nana. And tomorrow we discuss about some more questions. Nana, is clear what I am saying? Please tell me have any doubts. Simple explanation, Nana. No confusion. So thank you very much. Good night. Tell me have any doubts, please tell me, Nana. If you have any doubts, so I am responding to your doubts. Nana, the questions are very easy, not so much difficult. Easy explanation, so no confusion. Just you go for the IPE question bank. You have the blueprint, Star Academy material is there. In the Star Academy material, in IPE, any material, the 2 marks questions are there. Now once you listen the class by the good teachers, now easy to understand, easy to explain what kind of models are there. Because I explained questions, all questions are there in the previous papers. I am explaining questions, all there in the previous papers, Nana. No confusion of those questions. So just to refer, you go through the material as per the blueprint. You know the blueprint? So from this topic you have the very short, from this topic you have the short. and from the organic atomic structure, periodic classification, chemical bonding essay questions are there. Based on that, you get the marks. You go through the materials of the IPE. So as per the blueprint, you get good marks. And thank you very much.